Next is identify a subgoal. Another important strategy to use when solving math problems is to identify subgoals. Some problems need to be solved in steps, and then each steps can be solved separately. Many large and complex problems can be solved by using strategy.
Okay, here is the example for identify a sub-goal. So here is the problem. Suppose an assembly line is set up so that 3 workers can assemble 10 radios in 20 minutes. If all the workers on the assembly line work at the same rate, how many radios can 14 workers assemble in 90 minutes? The overall problem can be broken down into a number of steps. So, question, how long does it take one worker? If 3 workers can assemble 10 radios in 20 minutes, the rate of assembly for 3 workers is 10 over 20. Therefore, the rate of assembly for 1 worker will be 1/3 or 10 over 20 or 10 over 60. Since we don't know how many radios 14 workers can assemble in 60 minutes, let x equal the number of radios that 14 workers can assemble in 90 minutes. Therefore, the rate of assembly for 14 workers in 90 minutes will be x over 90. And for the worker will be 1 over 14 times x over 90 or x over 1260. Setting up and solving the equation. So let's solve it. Since the rate are equal for one worker on both sides, the equation 10 over 60 should equal to x over 1260. Therefore, 60x should equal to 12,600. Solve for x. So let's solve for x. Divide both sides of the equation by 60 so that x is equals to 210. In other words, 14 workers can assemble 210 radios in 90 minutes. So check the solution. Let's check for our answer. In order to check the solution, check to see if the rate of assembly for one worker is the same on both sides. In other words, is 10 over 60 equal to 210 over 1260? The fraction 10 over 60 is in simplest term is 1 over 6. And so, the fraction 210 over 1260. So our answer is correct.
Next, we have change your point of view. Of the many strategies that exist and that are available to us to solve mathematical problems, the one that allows us to avoid is running into a brick wall, namely avoiding frustration, is that approaching the problem from a different point of view. Perhaps one of the classic examples because of its simplicity and dramatic in solution method.
Adopting a different point of view. Let us consider the following problem. Suppose we cut out two opposite corners of a chessboard. If one domino can cover exactly 2 squares of a chessboard, can we cover the chessboard with 31 dominoes? If this is the first time you encounter this problem, you may wish to pause the video and think about it for a few minutes. The initial reaction is for students to say, well, of course, I have 31 dominoes, and 31 times 2 is 62, and since I cut out 2 opposite corners, I have 62 squares, so of course I can cover it. So you say, so show me how to do it. And they start trying to come up with a way of arranging the domino tiles so that it works, and they try and try and try, and nothing seems to work. And they realize that something is missing, something is wrong. And then they might consider the coloring of the chessboard. So this is a change of viewpoint. And they will realize that it doesn't matter whether you place a domino horizontally or vertically, it always covers exactly one dark square and one light square. And when we cut out 2 opposite corners, notice what happens. You cut out 2 opposite corners and they have the same color. In this particular case, we have cut out two dark corners. So we have 32 light squares and 30 dark squares. So with 31 dominoes, each of which must cover a dark and a light square, with 31 we want to cover 32 light squares, which is impossible.
Next is direct reasoning. The use of direct reasoning strategy is used virtually all the time in conjunction with other strategies when solving problems. Direct reasoning is used to reach a valid conclusion from a series of statements. Lastly, we have indirect reasoning. It is a method of proof whereby one assumes the opposite of the conclusion to be proved and works through logical deductive reasoning to establish a contradiction. If there's no error in the logic, then the assumption must be false and the original conclusion holds true.
Two kinds of reasoning, and you heard that one already, namely direct and indirect reasoning. This time, we're going to write the first sentence only of an indirect proof of its positional shown. Example, if AB equals BC, then triangle ABC is not isosceles. So where's now our conclusion? Yes, exactly. The triangle ABC is not isosceles. Therefore, we're going to assume incorrectly that triangle ABC is example number 2. If n squared is greater than 6n, then n is not equal to 4. So the conclusion is n should not be equal to 4. Therefore, we are going to assume again incorrectly that n equals 4. Example number 3. If measure of angle 1 equals measure of angle 2, then line segment XY is parallel to line segment CD. So the conclusion is line segment XY is parallel to line segment CD. The same method, we're going to assume temporarily that line segment XY is not parallel to line segment CD. So let's go now to direct reasoning. Example, we say the integer n is even if there is an integer a such that n equals to a. We say n is odd if there is a such that n equals to a plus 1. To understand this example, let's represent a in an integer. If k equals 4, then we're going to substitute k for 4. So that is 2 times 4 is equal to 8. If k equals 5, then 2 times 5 is equal to 10. And if k equals negative 3, then 2 times negative 3 is equal to negative 3. But how about the formula of an integer where n is odd and n equals 2k plus 1? If k equals 1, then 2 times 1 plus 1 is equal to 3. If k equals 4, then 2 times 4 plus 1 equals 9. And if k equals negative 3, then 2 times negative 3 plus 1 that is equal to negative 5. So this time, we're going to identify if it's either direct and indirect reasoning, and let's finish the proof. Number 1. If n is an integer and n squared is odd, then n is odd. First, we assume that the opposite of n is odd. So this is indirect reasoning. So we assume that the opposite of n is odd. Therefore, n is even. If n is even, then n equals OK, where k is an integer, just like our example a while ago, right? Now, square n and see what happens. This becomes n squared plus 2k raised to 2, that is equal to 4k squared. This means that n squared is a multiple of 4. No odd number can be divided evenly by an even number, just like this. So this contradicts our assumption that n is even. Therefore, n must be added to n squared opposite parity, then their sum is odd. Suppose M and N are two integers with opposite parity. This is, yes, direct reasoning. Suppose M and N are two integers with opposite parity. So the opposite parity refers to odd and even. We need to show now that M plus N is odd. Thus M equals 2A and N equals 2B plus 1. For only integers A. Therefore, M plus N equals 2A plus 2B plus 1 equal to 2 times A plus B plus 1, which is odd. It's because whatever the value of A plus B, either positive even, positive or negative integer, when it comes to this formula, then the result is odd. So we can see that the conclusion is proven out of those previous statements, and that is direct reasoning. Number 3. If n is even, so n squared is even. So assume that n is uneven. So this is direct reasoning. So assume that n is uneven, and because n is even, so n equals to k. For any integer k. Example. So now, if we're going to square this 2, then this becomes n squared equals 2 times 2p squared. And if we let j equals 2p squared, then n squared equals 2j. So n is even. It's because any integer that will substitute for j, the result is always even. Example number 4. If x equals 2, then 3x minus 5 is equal to 10. If x equals 2, then 3x minus 5 equals 10. So this is indirect reasoning. If x equals 2, then 3x minus 5 equals 10. So we take these statements as true and solve for x. 3x minus 5 equals 10. So by addition property, that becomes 3x equals 15. By division property, that becomes x equals 5. So this contradicts the given statement that x equals 2. Hence, our assumption is incorrect and 3x minus 5 that equals 10 is
Here are the references for our topic. We have 18 references. Thank you and God bless everyone.